Clearly? Okay. I want to welcome you to another statistical class. And of course, the focus today will be on gathering data. Okay, so how do we find ourselves, in a situation where we need to gather data? Why we need to collect data? Okay, because we actually want to make sure we want to understand our environment. Okay. So, and of course, for us to be able to understand our environment, we need information, right? And the information is going to come from data. Okay. Now, the way data is collected matters a lot. Okay. Uh, we expect data to be collected in a way that that particular data set will be enough to answer research question. And at the end of the day, we actually, whatever recommendation from the findings will make sense. So, and that is the reason why we need to be able to understand some statistical ideology when it comes to collecting data. Okay, so and that is going to be in focus today. How, because the way we collect this data matters, okay? And that's why you need to be guided statistically on how we do that. Okay, so in the learning goal, you're actually going to learn, you're going to understand how to determine which type of study is possible. Okay, we got two type of study. We got observation study and we got experimental study. So we want to be able to decide, what are we going to see before we can actually go for which one. Okay. So I'm going to walk you through that today. And another reason, another goal is how good to take a sample, because when we identify the population of interest, we are not going to study everybody. We're limited by budget. We don't have time. All what we normally do most of the time is to take sample. Okay, so how good to take a sample? Because the manner in which samples are taken matters. That could affect results. And that is the reason why you also need to be guided on a good and bad way to take a sample. Then you're also going to understand a good or bad way to experiment. Okay, so that will be the focus today. Okay, so I'm actually going to start with determine which type of study is possible. Okay, so let me I'll tell you this. We got two type of study. Okay, we got observation. Okay, so we got observation. Okay, so we got observational study. Okay, and we actually have experimental study. Okay, we need to first decide, okay, which one are we going to choose? What do I mean by observational study? What do I mean by experimental study? I needed to take to pay attention now. In observation study, okay, we observer, the researchers observe, use historical data, okay? It just base his findings on historical data, okay? Observer, the researcher don't manipulate variables, okay? But in experimental study, okay, the researcher will manipulate variables. The researchers will assign participants into groups, Okay. Now, let me tell you this. In statistical analysis, experimental study has a very huge statistical power as compared to the observational study. But the issue with experimental study is that you need a lot of resources, okay, and there's a lot of ethical issues, which I'm actually going to disclose right now. But observational study is another very good alternative, okay, but we need to first decide which of these we actually going to undertake. Now, what's actually determine the choice between the observation and experimental study? Number one is ethical considerations. For instance, I want to look at the effect of smoking on the risk of getting lung cancer. Okay. If I'm going to using experimental study, that means I will actually hack some people to start smoking, while some will not smoke. So it means I'm exposing them to maybe danger or something. Okay, that's not ethical. Okay, and what I can just do in that situation, I can look at record. Okay, those who have smoked before, and do they have history of lung cancer? That's why when you go to a clinic, the officials in the clinic, they will collect data over a lot of variables. They're going to ask you to indicate your gender, your age, whether you smoke or not, and so on like that. Okay, so on ethical consideration, okay, we may prefer using the observation study instead of experimental study. Now, control over variable. If you have control over the variable of interest, for instance, in December 10, 2020, there was an article published in the New England Journal of Medicine in the state of Massachusetts in the United States. Pfizer claimed, that was in the middle of pandemic, the Pfizer claimed that they've discovered vaccine for COVID. What they did, they conducted an experimental study where they divided, they assigned participants into two groups. Okay, one group received the vaccine, the other group did not. The other group received placebo. Placebo is used as a control. In that situation, and what Pfizer did, I think they give the participants in the experimental group the first dose, and after 3 weeks, they give them second dose. So doing that, it's like you have a control over the variable. So that is experimental study. So when you have control over the variable, you can manipulate the variable, you can assign participant to group. Of course, you're actually going to go for experimental study. Now, another reason why, okay, go ahead. Oh, about the Pfizer stuff? Go ahead. Okay, this is what Pfizer did. They have two groups. This group, when you're performing experimental study, okay, you need to have two groups. One is control, the other one is the treatment group. Now, this group received the vaccine first dose. This group received placebo. Placebo is a drug, but it doesn't have any effect. Those people in this group, they're going to have the belief they are also receiving vaccine. Does that make sense? But it's not. It's nothing. So this is treatment group. So they're going to make sure the participant in this group, They give them the first dose of the vaccine. They also give the people here the first dose of the placebo. After 3 weeks, they come back and give their second dose. These people here receive second dose. The one in the placebo group also received second dose. Now, what the Pfizer did, they exposed them to society where there is COVID. And what they want to do is they want to see what is the proportion of those who receive vaccine will catch COVID. What is the proportion of those who do not will catch COVID? So for, they say they have 95% efficacy. So which means if 100% of people were given their vaccine, right, 95% will not catch COVID. Does that make sense now? That what they did was an experimental study. Does that make sense? Okay. And doing that, they controls for other variables that we call confounding variable, like they look at the pre-existing conditions and so on, like that. They believe that under certain condition, that is going to be great. So I'm still going to explain all of that. Now, causality versus association. If I'm only looking at the relationship between variables, I'll go for observation. Maybe, for instance, I want to look at the relationship between, state tax and the price of gas. If the relationship exists between state tax and the price of gas, that doesn't mean state tax causes the price of gas. Okay? Association does not imply causality. Causality means I want to see whether this caused this. If I want to investigate whether this caused this, then I will go for experimental study. If I'm looking for association only, relationship, I will go for the observation. Does that make sense? Okay. Now, feasibility and resources. For instance, if I want to look at the effect of, if I want to look at the relationship between your SAT score and the college GPA, the SAT score and the college GPA, okay, performing an experimental study is not visible. Because am I going to have some student to go and write SAT? But I can just look into the record of the current college students. They already have their SAT score and they have their grade. So observational study will be more feasible in that regard. So which means the type of research question, okay, determines whether you're going to choose this or choose that. And you also need to look at the resources available. In research, we're limited by budget. We are limited by budget. Okay, we want to make sure that whatever we do save costs, at the same time save time. Then the nature of research question. That was what I said the other time. The nature of research question, we actually determine whether. Let me tell you this. If your research is to introduce an effect, just like the way Pfizer did. Pfizer was trying to introduce an effect, that they're trying to introduce that, oh, this treatment has effect, the vaccine has effect. Okay, now in that situation, we actually need to use an experimental study to be able to do that, because we are introducing an effect. We don't need, so the nature of research question will determine your choice of the type of study, whether you're going to go for experimental or observational study. And lastly, external validity. Please, I will need you to pay a lot of attention. Okay, need you to pay attention. By external validity, what do I mean? The external validity, refers to the extent to which the result that you got can be generalized. Okay, outside the condition of the experiment, okay, to several settings. Okay, and I'm going to give you factors that determine external validity. Number one factor that determines external validity is population generalizability. Like, for instance, I actually look at the effect of new teaching method, maybe for a specific university students. Now, can I generalize that across the region of university student, or can I even generalize that to high school students? Okay, or can I generalize that across location, just like what Pfizer did as well? Okay, does the vaccine only work for people in the United States? Can the vaccine also be used across regions as well like that? That's what we mean by population generalizability. Okay, another factor that determines external validity is geological validity. Okay, what do I mean by geological validity? If I conduct an experiment in a highly controlled laboratory, okay, can the result be generalized to everyday setting? I'm going to say that again. I conduct an experiment, okay, in highly controlled laboratory, okay, can the result of that findings be generalized to everyday setting outside the laboratory? That's exactly what I mean. Another factor that determines external validity is temporal. Okay, temporal. Let me write that. Temporal validity. Okay, temporal. Okay, you know, I was talking about factor that determine. I think I've talked about population or generalization. I just talked about population. Okay, I've talked about geological. Okay, right now I want to talk about temporal. Temporal means, can I generalize this result across different time periods? A study conducted in 1980. Can the result be applied to today's world? Okay, don't forget we have a change in technology, a change in social norm, a change in culture. That is what we mean. Okay, so that is what external the temporal validity talk about. Now, the next thing I want to talk about is what's, using already available data. For instance, if you want to conduct an observational study where you don't necessarily need to manipulate, you actually want to use historical data. There are some websites you can see data set, okay? Because they conducted general survey. If you go to each of these websites, particularly if you go to the firststart.site, the USA Gov, you're actually going to see some data depending on what you're looking for. Okay, these are other site that's for data. Now, I want to go into ways of collecting data. We got two ways of collecting data. We have census and we have sample survey. So what do we mean by census? Census is when you have a complete enumeration. You study everybody, okay? Why sample survey is when you take a sample from the population. And that's what we do most of the time. You know, we don't have enough time to study everybody in a population. Okay. And of course, the general social survey, okay, is an example of a sample survey because, that's actually gather information, by trying to interview, a sample of a subject from the United States adult population. They really want to have a snapshot of that population. Okay, they may want to ask questions about election, or they want to ask about people's perception about the policy of government and so on like that. Okay, now we do that all the time. Now the next thing I want to talk about is if I have an exercise like this, we actually talking about high blood pressure and binge drinking. We can give you a scenario and ask you to identify whether the type of study that's appropriate. Whether are you going to choose observation or you're going to choose experiment. We can give you a scenario like this. And not only that, we can also ask you to identify what are the variables involved. Okay, when you are looking into relational analysis, okay, we got two types of variable. Okay, we have explanatory variable, the one that explain the other variable. Okay, and we have what we call the response variable. The response variable can also be called outcome variable, can also be called dependent variable, So we got variables involved. Now take a look at this. Many studies have demonstrated that high blood pressure increases the risk of developing heart disease or having a stroke. It's also safe to say the health risk associated with drinking far outweighs any benefit. A study published in Health magazine in 2010 suggested that a combination of the two could be a leader miss. As part of the study, okay, that follows 6,100 South Korean men aged 55 and over for 2 decades. Okay, now if you take a look at this, they talk about men, right, and age 55. Okay, this may not be generalized to women or to other age brackets. Okay, now with high blood pressure who being drank even occasionally at double the risk of dying from stroke or a heart attack when compared to the T-12ers with normal blood pressure. Now the question is asking, is this an observational study or experimental study? Of course, this is going to be obviously observational study because there's no way they can actually randomize or assign participants, okay, to this. Then identify the explanatory variable and the response variable. Of course, the explanatory variable here will be high blood pressure and the binge drinker status. And the response is either you have event of death or not, okay, or whether somebody have heart attack or stroke and so on like that, okay. And the next question said, does the study prove that a combination of high blood pressure and binge drinking, because the high blood pressure and binge drinking, these are explanatory variables. They are explaining the status, okay. Now the question now is, can we say that that causes an increase? Now, if you really want to answer a question that has to do with causality, okay, you can only answer a question on causality when you are conducting experimental study. But when you are conducting observational study, you cannot conclude on causality. Even though relationship may exist between this and that and the response, but you cannot really say the two variable cause that. That is what we mean. And how do I know? Because I know we're working with the observational study. But with the experimental study, of course, we can have that kind of conclusion. Now, to experiment or to observe, okay, there's so many questions. Okay, I think if you check assignment 1, I think a question like that come up. Okay, now this scenario, so the first one, whether smoking influences coronary heart disease. I'm not going to ask people to start smoking or not. Because of that, I'm going to use observational study for that. Okay, on ethical ground. Then the second one, whether higher SAT score tend to positively associated with the higher college GPA, it will be feasible. Sorry, it may not be feasible for me to also manipulate student grade. So I'm also going to look into record. Observational study is also going to work. Whether a special coupon attached to the outside of a catalog makes recipient more likely to order product. Of course, if you take a look at it, I can do experiments. Okay, here they can have 2 sets of customers where they give some special coupon and they don't give the other group special coupon, and they want to compare their what? They want to compare their purchasing power. They want to see whether they can attribute, the higher purchasing power to the fact that they gave out special coupon. Okay, so take a look at that. Now, the next objective of the day is a good and poor way to sample. Now, let me tell you this. Before I go into all of this, when you want to talk about good and poor way to sample, the moment you understand the good way to sample, when you go against the good way to sample, then you are doing a poor way to sample. The number one is randomness. Because you're going to be taking sample from the population, you need to give equal chance to the participants. Okay, randomness is number one. Number two is appropriate sample size. I want to have a study now. How do I know about what is the number of sample size that do I need? What is the number of participants? In statistical framework, we prefer working with large sample. Okay, but let me tell you this: how large is large? We're going to tell you, because when you continue to increase your sample size, the law of diminishing returns can set in, where increase of the sample size may not bring any significant effect. Okay, like I said, we're going to tell you how large this is the large as time goes on. Okay, now appropriate, you need to, like I said number one, randomness. The way you choose your sample has to be random. That is randomness. Number two, appropriate sample size. Because of that, in the course of our lecture in this course, I'm gonna show you formula. We got a formula that we use to figure out sample size. We call it sample size determination. Number three is the representative of the population. If you choose a sample that is a very good representative of a population, the one that reflects key important variables. When I say key important variable, does it cut across age? Does it cut across race? And so on like that. Those key variables must not be missing out. Number four is what I'm actually calling the use of proper sampling techniques. I'm going to walk you through sampling techniques. When you resolve to taking sample, what are the appropriate sampling techniques that we have? We're going to discuss them one after the other. Then minimization of bias. We need to make sure you spend most of the time minimizing bias. Okay, there's a particular type of sampling approach that you should avoid, like convenience sampling. I'm going to discuss that. But you know what I want to do right now? What I'm going to do right now, before going into sampling techniques that we have, I will first tell you sampling frame. Let me tell you this. If I want to conduct a study, okay, I will need to go to a population. Let's say, for instance, I want to conduct a study in this university. I actually want to know what, on average, how many hours students commit to study in a week. Okay, now the population of interest is the University of Minnesota. But what is my sampling frame? My sampling frame is not going to be all students in the University of Minnesota. I'm going to say this again. My sampling frame will be registered students. It's not, there are some students that didn't register. Okay, now that is the sampling frame. The sampling frame could be smaller than the population. Now, I'm now going to take my sample from the sampling frame. Let me give you another example. Election is coming in the United States, okay? And maybe we're curious to know the chance of a particular candidate, okay? Of course, the population of interest will be the people in the United States, but it can't be all people in the United States. It's actually going to be those who have registered to vote. That is what we call sampling frame. Does that make sense? Okay, now that I have my sampling frame, the next thing is I want to talk about sampling techniques that I'm going to use. Okay, these are very, very crucial. Okay, we use these techniques when we're not interested in census. We're not interested in investigating everybody. We're only interested in a sample. Okay, now let me tell you, I'm going to start with a simple random sample. When do we use simple random sampling? We use simple random sampling when the population is homogeneous, when everybody is more or less the same, putting into consideration characteristics of interest. I can do simple random sampling. I can close. For instance, if I assume that maybe I want 5 people to represent this class, and I realize that you are all intelligent, like you very like the population here is homogeneous. The difference is not, even though different exists, but that very difference is not very much pronounced. I can close my eyes and pick on anybody. That's simple, understand. That's what they use in lottery. But let me tell you this: when I close my eyes and pick on anybody, there's possibility. Let's say I'm conducting a study in a state, in a particular state, and I'm using a simple random sampling. Okay, there's possibility I may choose a part that does not really reflect the overall population because of the fact that there's heterogeneity, in the population. Now, what I can do with that is, if the population is heterogeneous, what I'm actually going to do is to use what I call stratify. Okay, now let's see the difference between number 1 and 3. The simple random sampling is when the population is homogeneous. They are more or less the same. I can pick on anybody. But situation where they are more not the same in terms of the characteristics of interest, then you know what I'm going to do. I need to first subdivide. But before going there, let me first show you a picture for simple random sampling. Now, for simple random sampling, I have these people now. Okay, I can just close my eyes and pick on anybody. This is my sample at the end of the day. My sample is going to be smaller than the population. Take a look at that. Can you see that now? Okay, but this approach is not good if the population is heterogeneous, when they are not the same in terms of the characteristics of interest. Now, we have what we call cluster sampling. The idea of a cluster sampling work when you have natural growth that are present in a population. Okay, for instance, we are in Minnesota and we want to conduct a study. We can divide Minnesota into maybe by county. There's Anoka County, there's NAP County. So if we divide by county, let's say we have like 20 county. Okay, we're only going to choose maybe 4 county randomly. So county here is a cluster. Okay, so and that's exactly what I'm doing here. Take a look at this. If 1, 2, 3 is a cluster, 3, 4, 5, 6 is a cluster, 7, 8, 9 is a cluster, 10, 11, these are cluster. I can pick 2 cluster randomly. Okay, and whichever cluster that I pick, that is where I'm going to conduct my study. That's what we mean by that. Now the next one is stratified sampling. In stratified sampling, the population is heterogeneous. Okay, the idea of simple random sampling is not going to work because they're heterogeneous. Then you need to stratify, you need to subdivide the population into different groups. You need to define your agent of stratification. Could be income. Your agent of stratification could be race. Your agent of classification could be age bracket. Okay, so after dividing them into different groups in such a way that in each group they are the same within a group. But when you put them together, they are not the same. So what you're going to do, you're going to go from each group and pick. You're going to go from this group, you pick, from this group, you pick, from that group, you pick. By the time you combine your sample together, that sample will be a very good representative of the population. A question? Okay, let's now, so stuff like this. The population here is heterogeneous. I stratify into two different groups, but I will need to tell the world what is my agent of stratification. Does that make sense? Then from each group, I'm actually going to choose. Then this is a combined sample. This is going to actually, reflect the diversity in the heterogeneous population. Now the next is systematic. Oh my God. Police use this technique most of the time. When police pull you over, okay, it's not all the time that somebody commit crime that they pull somebody over. They pulled me over before. Now this will happen. They're going to decide, okay, today when they are patrolling, they're going to say, okay, they will stop every fifth car, which means number one, number two, number three, number four, they're not going to stop them. They will stop number five. After number five, they will stop number 10, number 15, and so on. That's what we call systematic sampling. The idea of a systematic sampling is to get across, to cut across the population. So it's actually, take a look at this. I got 1 to 9. We interview number 3. We go to number 6. After number 6, we go to number 9. That's like having interval of 3. They're going to decide on the interval. Does that make sense? Now, every sampling technique that I've been discussing before now, they are probability sampling. Okay? They actually ensure randomness. But take a look at this, convenience. This is not a good way to sample. Convenience is just like, I go into mall and I just come across somebody and I interview the person. Okay? Now, take a look at this. I got a lot of people, and maybe I just come in contact with these people and I just interview them. Convenience sampling is not a good sampling. It's not a good sampling technique. Okay, this is going to lead to bias, and that will not invalidate your result. Okay, so this is not a good way to sample. Now we also have another one, voluntary sample. The voluntary is on average a good way because at times maybe we want to test a drug, right? Want to see whether a drug work, and we ask people to volunteer. Okay, but at times it's not a good idea. Okay, I remember there was a particular incident where some people, like in a party, like if you want to ask a political question, okay, and you want to use a volunteer approach, there's possibility majority from a particular party may dominate, and that's why that may not be a good idea. Okay, now when you have a poor, for you to have a very good way of taking a sample, you actually need to have a good sampling frame. If you have a poor sampling frame, that's not good at all. Now I'm going to demonstrate to you. There was one what is it called? A pollster that predicted presidential election in the United States correctly before 1936. And that was why I said an example. And let me tell you this, even if your sampling frame is poor, even if your samples is large, okay, that will not still make your result to be fantastic because of this incident. Okay, a poll in 1936 to predict the presidential election, okay, and that very election between the incumbent, the Democrat Franklin Roosevelt, okay, and Landon, a Republican, okay. But do you know the sampling frame this guy used? At the time, the Maxim poll were FOMO because they had correctly predicted 3 successive elections. But in 1936, Literary Digest made questionnaire to 10 million people and asked how they plan to vote. But do you know their sampling frame? The sampling frame was constructed from telephone directories. Imagine that. There are some eligible voters that don't have their phone registered in that directory. Okay? Club member, country club membership, there are some voters that are not that membership. They don't have that membership. And automobile registrations. Out of how many? 10 million, 2.3 million people return the questionnaire. 2.3 million, that's a lot. You're going to be thinking that because you have a large sample, that is going to make sense, but you're going to see the reason why it doesn't make sense, even with the large sample, when you have a poor sampling frame. The digest predicted that London will win, getting 57% of the votes. But you know what happened instead? London actually got only 36%. Okay, and the Roosevelt won in the last slide. So don't always trust whatever what the poster tell you. Go ahead. About the forward. Okay, go ahead. Okay, now a large sample size does not guarantee an unbiased sample. If you use a very poor sampling frame, just like the one I demonstrated. Now I want to go into experiments. Now you've heard about how good and bad, okay, to sample. What about to experiment? We are assuming we actually want to do experimental study. Now, let me tell you, number one, the good way to experiment, number one is for you to have a very clear hypothesis and your research questions. Your hypothesis have to be clear. What do you want to test? Does that make sense? That is number one. Maybe you want to answer a question: does a drug A lower blood pressure or not, or compared to placebo? Okay, so you must have a very clear stated hypothesis. Then number two, randomization. Let me tell you this: there's a difference between randomization and randomness. They are not the same. When you talk about randomness has to do with the way you choose sample, when you give equal chance to everybody. But randomization is when you assign participants into two different groups. In such a way that any participant can go as equal chance of going into any of the groups. Does that make sense? That was what Pfizer did. They are not just picking them and say, okay, you go there, you go there. No. All the participants, in fact, what they would do, they will assign them to the group in such a way that the group can attract a equal chance. That's what we mean by randomization. Number three, there must be control group. Whenever you are experimenting, the control group is like a group of no effect. It's like you are comparing nothing with effect, with treatment. There should be a group to compare for comparison, the baseline. That's what we mean. Number four, blinding. What do we mean by blinding? Okay, so the blinding actually means those who are receiving, those participants, they shouldn't know the category they belong. All what they have in mind is that they are receiving treatment. Because if they know, that could affect result. If it could be single blind or double blinding. The single blind is when the researcher know and the participant don't know. But double blinding is encouraged, where both of you don't even know. Okay? Then number five, appropriate sample size. Okay? How did the Pfizer decided on the number to put in this category. How do they decide on the number they put in the other category? Number 6 is replicability. When you conduct an experiment, it should be something that people can replicate. They can confirm. There is nothing like authoritarianism in science. I said it and it's going to be. No way. People should have way to verify. Okay? Then ethical consideration, appropriate time frame, and so on like that. So I put this. Identify your population, randomly assign participants to group, ensure blinding, monitor both group for a specific period. Pfizer did the same. Pfizer monitored them for a specific period. Okay? Now, define and measure outcome. You have to measure outcome. How many of those that receive Pfizer vaccine were able to prevent the occurrence of COVID? How many that do not receive? Okay, you have to do that. Then control for other factors. I want to believe Pfizer did this. You know, this is the way you can control for other factors. Randomization, when you randomize, okay, that will nullify the effect of third variable, effect of whether somebody have a pre-existing condition or not. That would have been averaged out when you randomize. Does that make sense? Okay. Then statistical analysis. You have to use appropriate statistical analysis. Okay. Now, control comparison group, randomization, blinding, like I said, then replication. And let me also tell you this. Let me tell you the way, there's something that we call blocking. Take a look at this. For instance, this is my sample. My sample may be heterogeneous. I can partition them into 3 blocks. Now, maybe I need to define what the block represents. Oh, maybe these people are in the United States, block 1, Europe, Africa. You remember that time where they want to see whether the vaccine made by Pfizer will also work in Africa and the Europe. Let's say this is typical, my sample is typical of the world, right? And the first group is United States, the second group is Europe, and this is Africa. Now, the people here, we're going to partition them into 2 groups. The intervention is the treatment group, those that will receive the vaccine, and the control group. Why are we doing this? This is blocking. We apply blocking when we realize that that is heterogeneous. Okay, so that is when we do that, because we don't want a situation whereby the difference in the performance of the vaccine across a group maybe is not caused by the vaccine, it's caused by the group. We don't want that. We want to isolate the effects of that particular group. That's what we call blocking. Okay, so I put this summary here that you can actually read. Okay, I put a summary here that you can read. Okay. So, story. Today's about story. That's where I'm going to stop. Okay, on Wednesday, we are starting a particular topic that I know that normally scares students. But you know what? The moment you just sit back, ask question, you're actually going to have walkover. It's probability. Okay? We're starting probability. So read probability. Make sure you have a good day, and bye for now, everyone. Okay. In cluster, in the whole place, they are more or less the same. We now subdivide them.
All right.
You know, since they are all the same, I will subdivide them. We can just pick 2 clusters out of 10 clusters.
So cluster is homogeneous?
Homogeneous. Like you have a very big population that is homogeneous, all right?
Okay, then what is stratified?
The stratified, I have a big population that is heterogeneous.
Okay.
And I want to subdivide them in such a way that in this group, they are all the same. In this group, they are all the same.
So you're not dividing them by like a trait, you're dividing them so that the same amount of each trait is in a group?
Yeah.
Okay.
Like, but if I want to divide them, I need to tell about what rule am I using, like agent or stratification.
Okay.
Like, am I dividing them using race?
Okay.
Am I dividing them using age bracket?
So are you like if you were dividing them by race?
Yeah.
Would you put all of the like every
African, like for instance now, African American in one group.
Okay.
The white in people in white group, then the Latino in one group.
And then you pick some from each.
Then I'm now gonna go into each group and choose randomly.
Okay.
Then I will combine. You know that is gonna
That makes sense.
that makes sense, right?
Yeah.
Yeah.
All the
How?
homework problems relating to our studios, are they going to be like solved in the lab or do we have to do them all on our own?
No, you're gonna do it on your own, not to the lab. You know, the knowledge you're gonna use to solve it is what you're gonna learn in the lab.
Okay.
That's why this week lab is very crucial
Okay.
to
Cool.
solving the R part of the problem.
So after this lab, we should attempt the problem then or?
Yeah, after the lab.
Okay.
Yeah, but you can attempt the theoretical
Yeah.
questions
Right.
for now, but you wait until the lab to attempt the arrow aspect.
Oh.
Yeah.
Thank you.
You're welcome. Yep.
Oh,
Oh, okay.
so you said very clear hypothesis, randomization, like a control group, and then the blinding where like one person knows, the other person doesn't, or both people just don't know what's happening.
Yeah, the single blinding is when the researcher know,
Yeah.
but the participant don't.